Okay, welcome to chapter section 4.3, dividing polynomials. Essential question is, how can you use the factors of a cubic polynomial to solve a division problem involving the polynomial? So what you will learn in this chapter section is how to use long division to divide polynomials by other polynomials. And then we're going to be introduced to something that is called synthetic division, to divide polynomials by binomials of the form x minus k. What is that? And we're going to learn how to use the remainder theorem. So without any further ado, okay, long division of polynomials. When you divide a polynomial f of x by a non-zero polynomial divisor d of x, okay, so f of x is a function that we're calling a polynomial, and d of x is a non-zero polynomial. We're calling it d of x because it's the divisor. You get a quotient polynomial we're going to call q of x, and a remainder polynomial r of x. So in general, if you take f of x divided by d of x, it equals q of x plus r of x divided by d of x, which just means it's the remainder divided by what you're dividing by, your dividend, or divisor, I mean, and that is if there is a remainder. If there's no remainder, just equal q of x. So the degree of the remainder must be less than the degree of the divisor. When the remainder is 0, the divisor divides evenly into the dividend. Also, the degree of the divisor is less than or equal to the degree of the dividend f of x. One way to divide polynomials is called polynomial long division. Okay, so let's take a look at our first example, which is dividing a polynomial degree 4 by a polynomial degree 2. So this is f of x. So let's just label this so that we get familiar with this. This is f of x, and this is d of x. Okay, our divisor. So we're going to take 2x to the 4th plus 3x cubed. So there's a 4, there's a 3, there is no x squared. So I'm going to say plus 0x squared. Make sure you don't forget that. Plus 5x minus 1. So it goes 4, 3, 2, 1, 0, degree 0. And we're going to divide that by x squared plus 3x plus 2. Okay, I didn't give myself enough room, so I had to move that over a little bit. All right, so now we have x squared plus 3x plus 2, and we're dividing this by this. So what you look at is your first term and your first term. And you ask yourself, how many times does x squared go into 4x, or 2x to the 4th divided by x squared? So off to the side, you could think of it as this: 2x to the 4th divided by x squared. Well, 2 divided by 1 is 2, and we get the x, and when we divide, we subtract our exponents, so 4 minus 2 is 2, so I'm going to get 2x squared. So you should start your answer lined up with your x squared term, because this is an x squared term, so this would be 2x squared. Okay, now let me just get rid of this circle here and this circle here. So now what we're going to do is we're going to multiply through. 2x squared times x squared is 2x to the 4th. 2x squared times 3x is 6x cubed. 2x squared times 2 is 4x squared. All right, so what I like to do is I like to put these in parentheses and put a minus sign, because that's what we're doing, we're subtracting. So we get this minus this is nothing. 3 minus 6 is negative 3x cubed. 0 minus 4x squared is negative 4x squared. You bring down your next term, plus 5x. Okay, it's just like regular long division, except there's variables involved. Not a big deal. All right, so now we're looking at x squared, and we're looking at negative 3x cubed. So off to the side, you could say, okay, negative 3x to the 3rd divided by x squared is going to equal negative 3 divided by 1, which is negative 3, and x cubed divided by x squared, which is x to the 3 minus 2, which is x to the 1, or simply x. So that's going to be minus 3x. Okay, now let me get rid of those circles. Okay, and now we're going to multiply through everything. Negative 3x times x is negative 3x cubed. Negative times a positive is negative. Watch your signs. 3 times 3, 9. X times x, x squared. Negative times a positive, negative. 3 times 2, 6x. Bring down your minus 1. Actually, that should continue like so. And we're going to, actually don't do that yet. I got ahead of myself. Let's do one more undo. Okay, subtract and put it in parentheses so you remember to subtract everything. So negative 3x cubed minus a negative 3x cubed means plus, that cancels to 0. Negative 4x squared minus a negative is plus 4. So it's negative 4 plus 9, which is 5x squared. Negative 5 minus a negative is plus 11x. And now I bring down my minus 1. Okay, and then finally, we look at our x squared again. We look at our 5x squared off to the side if you need to, but eventually you won't. I'm only going to do this one time. Focusing on the first term, we're just going to get 5. 5x squared divided by x squared is simply 5. Okay, so now let me get rid of these circles. All right, so here we go. I'm going to put a positive 5 here. So 5 times x squared is 5x squared. 5 times 3x is 15x. 5 times 2 is 10. Subtract the whole thing, and I get 5x squared minus 5x squared is 0. 11x minus 15x is negative 4x, and negative 1 minus 10 is negative 11. So I can't divide x squared. X squared will not go into 4x. Okay, once you get to a degree that's less than what you're dividing by, you are done. This is the remainder. So you'd say minus, because it's negative, and put 4x minus 11 over our d of x, which is x squared plus 3x plus 2. So this is our answer. We got 2x squared minus 3x plus 5 minus 4x minus 11 over x squared plus 3x plus 2. All we're doing is taking f of x, dividing it by d of x, and getting our q of x plus d of x, r of x over d of x. So let me just go back here. So this is what we just did. We took a function f of x, divided it by d of x, and we got q of x with a remainder. So this is q of x, this is r of x, divided by d of x. Okay, so that's how you use long division on polynomials. So now you should be able to do problems 5, 6, and 8 in your exercises. Okay, so now you're going to get an introduction to synthetic division, and synthetic division is you're going to get the same results as you did long division, but synthetic, we're just going to focus on a k. Let me highlight that. We're going to focus on k, and we're going to focus on the coefficients of our f of x. Okay, so we're going to look at this, and this has a leading coefficient of -1, and it's to the power of 3. And then we have a 4x squared. There is no x, so I'm going to call that 0x, and then a constant of 9. So those are just our coefficients in this f of x function. And what we're going to do is we're going to divide by our k. So in this case, k is 3 because it's x minus k. So it's always the opposite of what is here. If this was x plus 3, k would be -3. Okay, so x, in this case, k is +3. So to begin this, you put your k out in front, you draw a box like so. Let me draw that a little bit better. Okay. And you put your coefficients of your f of x inside. -1, 4, 0, and 9. You always bring down your first term and put it down below this line. You multiply here. 3 times -1 is -3, and you put your product under your next term. So 3 times -1 is -3, and then you add these two. 4 plus a -3 is +1. 3 times 1, 3. 0 plus 3, 3. 3 times 3, 9. 9 plus 9, 18. So this right here did not turn out to be 0. If it is 0, there is no remainder, and your k minus or x minus k would go into your f of x evenly with no remainder, but this has a remainder. So now all I need to do is convert this into a quadratic. So this is the constant term, the linear term, and the squared term. So we're getting one less than what we had. It was a cubic, and now it's a quadratic. So it's going to be negative x squared plus 1x, which is just x, plus 3. And my remainder is 18, and it's positive, so it's plus 18 over what we're dividing by, which was x minus 3. So there's our answer. We got negative x squared plus x plus 3 plus 18 over x minus 3. Okay, so that's how you do it with synthetic division. It is much easier than long division. So once you get a feel for synthetic, you probably will not go back to doing it with the long division. Okay, here's another example on synthetic division, and that's why I didn't tell you what problems go with example 2. Example 2 and 3 are using synthetic division, and then after this one, you should be able to do 11, 12, and 14. So since it's new, let's do another one. So we're dividing this, it goes 3, 2, 1, 0. There's nothing missing. Our coefficients are, let me highlight them this time instead. So we have a 3, we have a -2, we have a +2, and we have a -5. So those are the numbers we're going to write in our division problem. Where am I getting 5 from? 3, I'm looking at the constant. 3, -2, +2, and -5. And then you draw your bracket like so. And in this case, get my highlighter again. Okay, remember we are doing, let me go back a couple. X minus k. Let me bring that over to this example here. Whoops. So if I wrote x minus k, and that is equal to x plus 1, then k is -1, because x minus a -1 is x plus 1. So I want a -1 out here. Okay, it's always the opposite of the sign of the x plus 1 binomial we're dividing by. Okay. All right, so we're going to take and we bring down our first term. Boom. Multiply -1 times 3 and put the product underneath the next term. -2 plus a -3 is -5. -1 times a -5 is +5. 5 plus 2 is 7. -1 times 7 is -7. -5 plus a -7 is -12. This is my remainder. This is my first degree or 0 degree, first degree, second degree. So this is 3x squared minus 5x plus 7 minus 12 divided by my x plus 1. Okay, so this is our f of x. This is our d of x. This is our q of x, quotient, minus our r of x, which is 12, divided by d of x. Okay, so it's 3x squared minus 5x plus 7 minus 12 over x plus 1. Okay, so now you should be able to do 11, 12, and 14. Okay, the remainder theorem. The remainder in synthetic division process has an important interpretation. When you divide a polynomial f of x by d of x, it equals x minus k. The result is f of x divided by d of x equals q of x plus r of x over d of x. That's polynomial division. If we substitute x minus k in for d of x, we get f of x divided by x minus k equals q of x plus r of x divided by x minus k. Okay, following me? So f of x equals x minus k quantity times q of x plus r of x. So all we did there was divided both sides by x minus k. Or multiplied both sides, I mean. So multiplying x minus k on this side, let me just show that so you see what happened. We multiplied this by x minus k, this side, and we multiplied this side by x minus k, but we have to multiply every term. So this x minus k cancels, leaving us with f of x. X minus k times q of x is x minus k q of x, and then when I multiply this piece by x minus k, these cancel, leaving us with just r of x. So we multiply both sides by x minus k and we get this result. Because either r of x is 0 or the degree of r of x is less than the degree of x minus k, you know that r of x is a constant function. So let r of x equal r, where r is a real number, and evaluate f of x when x equals k. So if we have f of k, we're substituting in k for x, then up here we have f of k equals k minus k times q of k plus r. Well, k minus k is 0. 0 times q of k is just q of k, and 0 times q of k is 0. 0 plus r is r. So the result is stated in the remainder theorem. This result is stated in the remainder theorem, and we get f of k equals r. All right, let's take a look at that. Okay, core concept of the remainder theorem. If a polynomial, f of x, is divided by x minus k, then the remainder is r equals f of k. The remainder theorem tells you that synthetic division can be used to evaluate a polynomial function. So to evaluate f of x when x equals k, divide f of x by x minus k. The remainder will be f of k. So let's take a look at that in an example. That might not be clear yet, but hopefully after the examples it will be. Okay, so example 4 is much like example 3 and 2, but then we're going to discuss the remainder theorem in this example. So we have a 3, we have a 2, we have a 1, we have a 0. Nothing skipped. We don't need what I call a spacer. We don't need a zero placer. And we have x equals -4. All right, so we're going to use synthetic division. So we write the coefficients 5, -1, positive 13, and 29. And we draw our little thingy here, and we want x equals -4. So here it's not x minus k, it says x equals -4. So -4 is going to be what we're dividing by. It's going to go right there. We bring down our first term, 5. -4 times 5 is -20. -1 plus a -20 is -21. 4, negative times a negative is positive. 4 times 21 is 84. 84 plus 13 is 97. Number's getting pretty big here. All right, so we take 97 times a -4. It's going to be negative because it's a negative times a positive. 7 times 4 is 28. Carry the 2, put a little 2 up here. 9 times 4 is 36. Plus that 2 is 38. So we have -388 plus 29, which would be 378, 368, 359. So this is 359 on the negative side. Okay, so the remainder is -359. So by the remainder theorem, we can then state that f of -4 must equal negative 359. And we'll check it. So here's f of x. So I'm going to write it over here. F of negative 4 equals 5 times negative 4 cubed, I mean. It's an ugly 3. Negative 4 cubed. 5 times negative 4 cubed minus negative 4 squared plus 13 times negative 4 plus 29. So f of negative 4 equals 4 to the third power is 64, and it's negative 64, and it's negative 64 times 5, which is 20, and 6 times 5 is 32, so that's 320, and it's negative, because a negative to the third power is negative, and a negative times 5 is negative 320. Negative 4 squared is a positive 16, but it's minus that positive 16, or just simply minus 16. 4 times 3, and this is a positive times a negative, so it's minus again. 4 times 3 is 12. Carry the 1. 4 times 1 is 4, plus that 1 is 5, plus 29. So negative 320 minus 16 is negative 336. Minus another 50 would be 386. Minus 2 more is 388. And then add 30 to that, and we're back to 358. Actually, it's going to be 359, negative 359. Okay, I did that in my head, but it does come out, and f of negative 4 indeed does equal negative 359. So our remainder is the value of the function when we substitute in the value we're dividing by. That's all the remainder theorem states. So now you should be able to do numbers 25, 26, and 28 on your exercises. Okay, that brings us to the end of chapter 4.3. Hopefully you can divide polynomials using long division, synthetic division, and hopefully the remainder theorem is clear to you. So if you haven't done so already, please do these problems and have a great day.